Hey everyone, welcome to your own YouTube channel Tech with Ash. I'm so glad you are here. Today we are going on a friendly tour through the world of artificial intelligence. And I promise no computer science degree is required or previous learning is required. We'll keep everything plain and simple and in the most simplest way possible. So by the end of this video, we'll understand what LLM is, what AI agent actually do, how these things talks to each other, and tools people use to build with AI. Hit a subscribe button if you want more videos like this. Do let me know other topics you want to cover, and don't forget to like. So let's go. So here is what we are going to cover today. I have broken it into 6 topics. First, we'll zoom out and look at where AI fits in the big picture. Then we'll go into the world of large language models, what they actually are. After that, we'll understand context windows. Think context windows as an AI's short-term memory and what are the best ways to manage it, what significant role it plays. But then we'll talk about chatbots versus agents. And because they are very different things, we'll cover how agent talks to tools and to each other using protocols such as MCP and A2A. Finally, we'll look at a toolbox, LangChain, LangGraph, LangFuse, and no-code framework like n8n. Before we zoom into LLMs, let's see where they sit into a bigger picture. So artificial intelligence is the broadest category. It just means any technique that lets machine do something that normally requires human intelligence. Inside AI is machine learning, where instead of writing rules by hand, you let systems handle the pattern from data. Inside machine learning, there is a deep learning, which uses neural networks, layers of connected nodes loosely inspired by a brain. Consider it's like a network of electrical signals. Inside deep learning, there is a generative AI. So inside deep learning, there is a generative AI, a model that can actually create new things such as text responses, images, music, code. And right at the center, that's where large language models live. LLMs are specific kind of generative AI. They specialize in language. Things such as ChatGPT, Claude Gemini are the common examples or most known examples of LLM. So when someone says, I use AI to write an email, they almost certainly means LLM. So what actually a large language model is? Here is the simplest way to think. Think like an LLM is a really very good next word predictor. Imagine you are texting a friend and your phone suggests the next word. An LLM is like that, but trains on billions of web pages, books, articles, and code. So its predictions are extraordinarily good. So under the hood of LLM, there is a neural network. It reads your inputs, then generates a response as in one chunk at a time. So let's take an example here. So if your prompt is the cat sat on, it goes to LLM model. LLM model goes through the prediction and then predicts mat. And these chunks are called as tokens. A token is roughly 3/4 of the word. So on right, you can see the example. Here you see when you type the cat sat on the and the model predicts mat, that's one token at a time. So important thing here to understand is the model doesn't know the facts the way database does. It generates most statistically likely response based on its training. That's why it's sometimes confidently wrong. When model is confidently wrong, that phenomena is called as hallucination. Examples of LLMs you might have used like GPT from OpenAI, Claude from Anthropic, Gemini from Google, Llama from Meta. So let's talk about context windows. This is super important to understand. Every time you send a message to an AI, it doesn't remember your past conversation. Instead, everything it needs to know is stuffed into one big window called as context window. So think of it like a whiteboard. You can write on it your system instruction, your whole conversations, your documentation, and any other space. So the model reads entire whiteboard with a single time it responds. The size of the whiteboard is measured in tokens. Some model supports say 8K tokens, others supports 200,000 tokens. Imagine 200,000 tokens is roughly equal to 150,000 words of a novel. The chart here shows what takes up the space. Systems prompts are at the start, conversations history build-ups, and then file you paste in. Finally, whatever space is left is taken by the model context window. Two things you have to keep in mind. Bigger isn't always better. Stuffing too much things can actually confuse the model and cost a lot of money. Number two, when model window fills up, old messages are drops. The AI genuinely forget things it can no longer see. This is why memory and retrieval strategies, which will be covered into later sections, are such a big deal in agents. Now answer a question. What is the difference between chatbot and AI agent? They are actually very, very different. Chatbot is a simple. You send a message, it sends a one message back and then waits. One question, one answer, done. It's reactive. It's good and great for question and answer, drafting or brainstorming. However, on the other hand, agent is completely different. You give it a goal, like a book me cheapest flight to Lisbon, and it figures out on its own how to achieve that goal. It plans steps, takes actions, check results, and loop back until the job is done. So on the left hand side, you can see a chatbot answers the question as in reply, question in, reply out. On the right hand side, agent basically loops in, observe what's happening, plans what to do, and act by calling a tool. Then observe the result and decide next step. This loops repeats until the goal is finished. The key difference between is chatbot answers, agent acts. So how does agent actually take an action? Answer is through using tools. What is tools? You can say tool is just a function, a capability the agent can call. Maybe it's like search a web, or maybe it's like run this Python code, or maybe look things into a database. Agent, which is really just an LLM at its core, decides which tool to use based on the task. If your task is to read something from database, it will use the tool to read from database. If you want to scrape something from web, it will use the tool which facilitate web search. On this slide, you can see an agent in the middle connected to 6 different tools around outside. For a tool such as web search, calculator, code execution, email, APIs, file storage. This is what makes agent so powerful. A chatbot can only write a text. Agent can write a text and take real actions in the world. This is why agents are so powerful. Now, how do an agent actually connect to all those tools? This is where an MCP comes in. MCP stands for Model Context Protocol. It was created by Anthropic, the company behind Claude. It has become a widely adopted open standard. Here is an analogy I love. Think of an MCP as an USB-C for an AI. Before USB-C, every device had a different cable. After USB-C, one plug fits everything. The same chargers charge my watch, the same charger charge my phone, the headphones, and whatnot. MCP does the same thing for AI tools. Instead of writing a custom connections for every single tool your agent needs, you just build or use MCP server. Any agent that speaks MCP can plug in and use it. It is a standard way to expose your tools to be used by agents. So on this diagram, agent is at the top. So in this diagram, agent is at the top. It talks to the MCP server. That server connects to different tools such as database, files, SaaS apps through one single consistent protocol. That's MCP. So if you build an agent today and want to add Google Drive access tomorrow, you just plug in a Google Drive MCP server, no custom code. Now think about it. MCP handles agents talking to tools, but what about agent wants to talk to other agents? That's where A2A comes in. A2A stands for Agent to Agent Protocol. It can open a standard that lets independent AI agents discover each other and collaborate. Think an agent built within an organization which does a specific job, a specialized agent. You don't have to rebuild that functionality. Using A2A, your own agent can call that specialized agent and get a response back or get the task done. So even if it is built by completely different teams using different frameworks, it can work together. Think of it like an email. Email is a standard protocol. Gmail users can email Outlook users? No problem at all. A2A does the same thing for agents. It's a way to communicate between agents. On the right hand side, in this diagram, you can see mesh of 5 agents: travel, payments, calendar search, and an orchestration agent in the middle, all connected via A2A. A simple summary. If I want to summarize what's the difference between MCP and A2A, I would say MCP connects agent to tools and data, and A2A connects agents to other agents. You often use both together. MCP to call an API, A2A to coordinate with specialized agents. Okay, now we are getting into Builder's Toolkit. Let's talk about orchestration. When you are building a real AI application that calls multiple tools, makes decisions, loops through steps, you need some kind of framework to hold it all together. And that's orchestration tools do. One of the two most popular tools are LangChain and LangGraph. In simple word, if I want to explain you LangChain, it's good for building things happening in steps. For example, first prompts, then LLM call, then parsing, and then usage of a tool. It's linear, easy to read, easy to debug, perfect example for simple tasks. On the other hand, LangGraph is for more complex things. So instead of straight line, you will build a graph which branches through the loops connected via nodes. So this diagram shows multiple nodes are connected with dashed line looping back when agent needs to try again. So LangGraph gives you something LangChain doesn't: proper state management and checkpoints. If your agent crashes halfway through the task, LangGraph can pick up where it left off. So to summarize, LangChain for simple pipelines, LangGraph for stateful agent that makes decision and have a multiple or parallel runs. So your agent is running in production. How do you know if it's working well? That's where LangFuse comes in. LangFuse is an observability platform for agent LLM apps. Think of it as a Google Analytics, but for your AI agent. It tracks every step your agent takes and you can call it as a trace. It records how long each step took, how many tokens were used, what things cost, and whether the final answer was any good. So let's take an example. On the screen you can see there are 4 stat cards. You can say a typical day of an agent. For example, 1284 traces handled, 6.242 in API spend, 640 milliseconds average response time, and 94% quality score. So you can see on the bottom you can see an example of a trace. At the bottom is example trace. A user asks to book a flight to Lisbon. You can see every step, such as user input, LLM plans, search tool calls, LLM reasons, book tools, and final reply, each with its own timestamp. This is what LangFuse enables you. It gives you a debug capability around an agent to identify what went wrong and how can you improve over time. Without something like LangFuse, your agent is like a black box. What if you want to build an AI automations without writing a single line of code, or without writing a lot of code? That's what n8n is for. n8n is a visual workflow builder. You drag and drop nodes on a canvas. n8n is a visual workflow builder. You drag and drop nodes on canvas, connects them together, and build automation. Example on the slide shows a simple AI workflow. Say a new email arrives, that's a trigger. 2. AI classifies the emails and writes the summary. And 3. It branches. So if it is urgent, notify the team or log in a spreadsheet. So basically, to summarize, n8n is a drag drop, minimal code required, no Python, no API calls written by hand, just nodes connected together. So to summarize, n8n, a team can use n8n to drag and drop, minimal code, connects 400 apps and services, combine triggers, logics, and AI nodes at any times, and it's good for internal or business automations. So n8n is very popular for internal business automations, things like lead processing, support tickets, routing, content pipelines, and monitoring workflows. So let's put it all together. This is a big picture slide. Everything we have covered connected. So on the left hand side is you, the user. You send a message to the orchestrator. maybe built with LangGraph or LangChain. Orchestrator sends a task to the agent. The LLM actually thinks and acts. If agent needs to collaborate with other agents, it will use an A2A. Agent needs to call tools, it will call through MCP. An MCP server connects to all different kinds of different external tools such as database, API, SaaS. At the bottom there is LangFuse. It is observing all the time how your agent is performing, if anything is going it wrong. So n8n is a simple no-code automation that runs in every single thing on this diagram was covered in this video, from LLM at core to protocols connecting everything to tools that makes it observable and automatable. That's modern AI stack. Interesting? Let me know which topic you want to learn in detail. I'll cover some hands-on practices as well, sample example, and share the code. Comment in the chat if you want actual code implementing the entire workflows. So this glossary cheat sheet will help you to remember all the aspects. That's a wrap. You just went from what is AI all the way to agents, protocol, orchestration, full modern AI stack in one video. If this was helpful, please hit the like button. It really helps the channel. And subscribe if you want more videos breaking down complex tech in plain English. Drop a comment below what topic I should cover next. Maybe LangGraph deep dive, building a first rack pipeline, MCP hands-on tutorial. Let me know and I'll make it happen. Thank you so much for watching. I'll see you in the next one.